Okay, we're going to do an example of work. These problems are really pretty easy because it's just dealing with that simple equation. Work is equal to negative P external times delta V. So let me give you an example. A gas expands from 0.5 liters to 2.5 liters against an external pressure of, let's see, 1.00 atmospheres. How much work is done by the gas? Okay, simple. We go from half a liter to 2.5 liters, and we have an external pressure of 1 atmosphere. Work is equal to negative P external. And you don't need to write the ext, you can just write P delta V. So all we have to do here is plug in numbers. It's equal to negative P, 1.00 atmospheres times 2.5 liters minus 0.5 liters. And does it matter which way you set this up? Does it have to be final minus initial? Well, yeah, because notice it will change the value or the sign. It will change the sign of the answer, okay? So if you have this 0.5 minus 2, then you get a negative delta V. You end up with positive work. That means the system will have gained internal energy. Here, the system is losing internal energy. Okay? And this just works out to negative 2.0 liter atmospheres. And that is the correct unit for energy when we're doing PV work. So that's our final answer. Okay, let me just tack on a little bit to that because that wasn't nearly long enough. If the gas in the above problem gains 225 joules of heat in the process, what was its change in internal energy? All right. So there's our actual question, or there's a new question. What's the change in internal energy? That's what we're trying to find. Now we're given a heat. Heat is of course Q, not G. Now I'm writing like my 6-year-old son. Don't know the difference between a Q and a G. Okay. Q is 225 joules. So what's the equation for external or internal energy? Delta E is equal to Q plus W. This problem really couldn't be much easier, okay? Q is 225 joules. Work is negative 2.0 liter atmospheres. Anybody see a problem with this? Cannot add joules in liter atmospheres, okay? You have to have the same unit if you want to add numbers. So we cannot add that to that. That's a no-no, okay? So, simple way to fix that, just throw in a conversion factor. 101.3 joules. And I think I said 101 the other day in a different video. Doesn't matter. 101, 101.3 will still end up with the same answer to the correct number of sig figs. Okay. So, all we have to do is simplify. And we get 225 joules minus 202.6 joules. And that works out to a change in internal energy of 22 joules. Okay, what does that mean? Did it gain energy or did it lose energy? Well, the system gained energy. That's what this is telling us. Okay, that's it for this video.